Hi students, in class 12 PUC we started the topic ray optics and optical instruments. In that we have discussed about the refraction of light through the plane surfaces and refraction of the light through a lens. Then how is the light can be passes through the lens and how can it passes through the glass slab and how it is refracted through this lens and what happens to these focal lengths and refract indices of these lens, how is it related to the focal length of the lens we have seen. Now let us continue the topic of this ray optics and optical instruments from where we have stopped. That is what in the last session we have discussed about the refraction of the light through the lenses, that is about the lens maker's formula and focal length of the relations with the refract index. For different kinds of the lenses, obviously this focal length and refract index is related. These are things we have seen in the previous classes. Let me continue the topic of this chapter, which is the about these prism. As we know, the refraction, which is nothing but just once you assess your previous knowledge about this refraction of light, you know very well. Refraction is nothing but the change in path of the light when it is passes from one optical medium to the another optical medium when it is incident obliquely. When we are discussing about this refraction of light, we need to know the Snell's law of refraction, which are having more importance in this light and refraction of this light. That is what we know that the incident ray normal at the point of incidence and refracted ray all lie in the same plane. And one more, that the ratio of the sine of angle of incidence to the sine of angle of refraction is remains constant for a given pair of media. Whatever the media we have taken, either air or water, air or glass, for those particular pair of media, refractive index is remains constant. That is what we know on Snell's law of refraction. Sin I by sin r is equal to mu. Let me explain about the refraction. How is the refraction takes place through this prism? Let me show. This is what we know already, prism. And for this prism, you can observe how many surfaces are there. Here one triangular, and this is second one triangular. So that two triangular faces we have. And moreover, you can see here one rectangular face, and this is fourth, and this is five. That means overall we have three rectangular surfaces and two triangular surfaces in a prism. Now, for this one, how can the light can be refracted through this prism? Let us discuss. So, the refraction of light through a prism. Refraction of light through a prism. So before going to discuss about the refraction of light through the prism, let us know about the prism. What are the terms which are important to relate to this prism? Once if we have seen that if the light is passing through this prism, Wherever we have taken the support for this prism, then we call this as a base of the prism. Then whenever the light is incident on this first face of the prism, that one we call as a refracting face of the prism. Once if the light enters on this prism, first it gets refracted through this prism, means inside it is refracted, and again when it is coming from inside to the outside, which is from denser medium to the rarer medium, again it will be refracted. That means it is getting two times to be refracted. One is this surface and second one is refracted through this surface. So what we can call here, this is first refracting phase and it is second refracting phase. The light ray which is incident on first phase of the prism we call as a incident ray. The light ray which emerges from this second phase of the prism we call as a emergent ray. And the light ray which is passing through this prism, inside of the prism we call it as a refract. Now, these two refracting faces of this prism are supported by this edge, and this is called refracting edge of the prism. There is these two surfaces are maintain some angle. Now, the angle between these two refracting faces of the prism is called refracting angle of the prism. Refracting angle of the prism. Now, if you cut this prism perpendicular to this section, a part of the perpendicular section of a prism which is similar to this triangular, so that we call it as a triangular section of a prism. Let us remind me once, for this prism, how many plane surfaces are there? 5 we have. Do all the prisms have 5 plane surfaces? Is it? No, not necessary. Depending upon prism, even it may have 5, that is all different number of surfaces will be there, and it need not to be a triangular section of a prism. But we are taking here for our discussion triangular section of a prism. Let me take here ABC is a triangular section of a prism. ABC is a triangular section of a prism. This AB is first refracting phase and AC is what? Second refracting phase of the prism. Now what we know, the angle between these two refracting phases AB and AC is called what? Angle of prism. This is what? Angle of prism. And this is BC, where it is supported, that is what we have taken as a base of the prism. Let me take, whenever the light ray incident on first phase of the prism, it is refracted in a sort whatever, in what medium is this prism present? That medium, let us take the refract index is n. That means the refract index of the medium in which the glass prism is present is n1. Whereas refract index of this prism is n2. Is it? ABC is a triangular section of a prism. Triangular section of prism. N2 is a refractive index. Refractive index of a prism. Let us a light ray PQ is incident on first phase of the prism. Let me take here This is P and Q. PQ is a first face of the prism. Incident ray, PQ is a incident ray which is incident on first face of the prism. Whenever a light ray passes from one medium to the another medium, how is it refracted? Whether it refracted towards the base of the prism or away from the base of the prism, for this that is depends upon the norm. Let us take here, at this point we need to take the normal. That means for this AB you draw a normal. Now the angle between PQ is a incident ray to the normal is called angle of incidence. I1 is what? Angle of incidence. And when it passes through this into this glass and enters into this prism, again it will be refracted towards the normal of the prism, normal of the AB. Why? Now the ray is passing from rarer medium to the denser medium, where N2 is the refractive index of the prism, which is greater than that of the refractive index of the surrounding medium, so that light ray passes from rarer medium to the denser medium. You know very well, these are the basic concepts of the refraction. If the light ray passes from rarer medium to the denser medium, it bends towards the normal. If it passes from denser medium to the rarer medium, it bends away from the normal. So that towards which, how is it refracted inside? Towards the normal of the AB. Then it is bending towards the normal of the AB. Now we know very well, this is what refracted ray. QR is a refracted ray. QR is a refracted ray. Now the angle between normal to the refracted ray is called angle of refraction R1. This QR is incident again on second refracting phase AC. At this phase, that means here the light ray passing from glass to the A, so that it is passing from denser medium to the rarer medium. Once it passes from denser medium to the rarer medium, what happens? How it bends? It bends away from the normal. Away from the normal. Let me draw, so that what we have to draw at this point, again we need to draw the normal, is it? Let me draw here normal at this surface. N2, N. Now this is what R2. Now light ray pass from denser medium to it bends away from the normal. Now RS is called emergent ray, which is coming out of the prism. The light which is coming out of the prism is called emergent ray. RS is what? Emergent. Then the angle between normal to the emergent ray is called angle of emergence I2. Is it? Then let me write here what are I1, I2 are angle of incidence I1, I2 is what? Angle of emergence. R1, R2 are angle of refraction at first phase and second phase of the prism. One thing we have to understand clearly that when light enters on this prism, it gets deviated two times. How is it deviated? Two times. First time on this first phase of the prism and again at second phase of the prism. So that how many times it is getting deviated? Two times. From its original direction, it is deviating two times. Then what will be the total deviation of this light through this prism? That means deviation through this first face of the prism and deviation through the second face of the prism. To know that one, let me extend this incident ray PQ. Go on, extend. And this is what RS is emergent ray. Now, if you measure the angle between emergent ray to the direction of incident ray is taken as angle of deviation, and very important one, which is what is angle of deviation. Let me take here delta. This is let me extend this one. Yeah. Now this angle is delta. Delta is what? Angle of deviation. Is it okay? Angle of deviation means what? The angle between direction of incident ray to the emergent ray. Now let me write here angle of deviation. Delta is angle between emergent ray to the what? Emergent ray to the direction of incident ray. Direction of incident. Direction of incident. Now, our purpose is to find the angle of deviation of light through this prism. For this purpose, let me consider here it is what I1, R1, R2, I2. This is what delta. Delta is total deviation. But here delta 1, it is what delta. If you answer clearly from the quadrilateral AQNR, quadrilateral AQNR, that is what quadrilateral. And in this you can observe that quadrilateral angle Q is a 90 degree and even angle R is also 90 degree. Then what will be the sum of the remaining angles? A and this L should be a, what is it? 180 degree. It should be 180 degree. Sum of those two angles must be a 180 degree. So let me write here A plus angle QNR is equal to 180 degrees. Let me take it as a first equation. What do you mean by A? A is for what? Angle of prism, refracting angle of prism. A is angle of prism, refracting angle of prism. Similarly, we can observe clearly in this diagram triangle QNR. Triangle QNR. Triangle QNR. What is the sum of the angles in this triangle? 180 degree. Then R1 plus R2 plus angle QNR is equal to 180 degree. Let me write here from triangle QNR we can write R1 plus R2 plus what is this angle? N. QNR is equal to 180 degree. When we take this second equation. Now let us compare these two equations. What we can write from these two equations? A QNR 180, QNR 180. So we compare this one. What do you get? A is equal to what we can write here? R1 plus R. Therefore, here I am writing from equation 1 and 2 Since equation 1 and 2, A is equal to R1 plus R2. Let us take this is what third equation. Now, but our purpose is to find what angle of deviation of this prism or angle of minimum deviation of the prism from the total deviation. If you observe here, MQR from the triangle MQR, Q and R are interior angles, whereas M is what? Exterior angle. Let us take LMR is exterior angle and MQR, MRQ are interior angles. Then the total angle of deviation, delta, which is nothing but angle LMR is equal to exterior angle, must be equal to the sum of the interior angles MQR and MRQ. Angle MQR plus angle MRQ. We know already here LMR, which is nothing but delta, is equal to. Then what would be this angle? Here it is I1 and this is vertical opposite angles. Then here totally should be I1, but here already we have R1. This is I1 minus R. Delta 1 is equal to MQR is equal to what? I1 minus R plus. Similarly, this is R2 and it is I2, angle of emergence. Then these two must be equal, these angles. Then this is what? I2 minus R. I2 minus R. Even I2 minus R2. Now delta is equal to, let me write the I1 and I2 at one place. I1 plus I2 minus, what you can write here? Minus R1 minus R2. So that combining these two, you can write as minus of R1 plus R2. Therefore, delta is equal to I1 plus I2 minus, what do you mean by this R1 plus R2 from the equation 3? You can write that R1 plus R2 is equal to A. Then let us take this as fourth equation. Delta is equal to I1 plus I2 minus A is the fourth equation. This is very important expression. Here even you can write this expression as delta plus A is equal to I1 plus I2. That means angle of deviation plus angle of prism is equal to the sum of the angle of incidence and angle of emergence. I1 I2 means what we know already. I1 is angle of incidence and I2 is angle of emergence, so that you can write delta plus A is equal to I1 plus I2. Now, if you have taken a prism, for this prism, if the light ray is incident on one face of the prism, if you have taken prism in this position, let us take the light ray is incident at this place. That means you take a laser light. Let us make incident on one face of the prism. Now, slightly you change or slightly you rotate this prism. Then what will be happen? If it is incident ray at this space normal, if you have taken normal, this is what angle of incidence. Now if you rotate this prism, what happens? Angle of incidence will be changed. Whenever the angle of incidence changes, then the deviation, angle of emergence also changes, and angle of deviation also changes. For that, by drawing this experiment, by calculating, by taking prism and some pins as a incident ray. Let us take on this incident ray. If you take two pins and observe from other end of the prism, insert third pin in the line of these two pins, and also fourth pin in the line of these two pins, and these two pins will be act as a refracted ray, and these two pins if we join, it will be as a incident. Now by changing angles we can get the angles of incidence. Even by drawing this, even you can get the angle of deviation. Let us take, for example, I1 is angle of incidence, I2 is angle of emergence, delta is the angle of deviation. By drawing these diagrams or by doing this experiment for different angles of incidence, let me take for 70 degree. If you take the angle of incidence 70 degree, for this the angle of emergence is 33 degree. Corresponding deviation will get as 43. Similarly, if you take I1 as 48 degree, 48 degree, corresponding angle of emergence will get 48 degree. And for this the deviation is 36 degree. 36 degree. Similarly, let me take for 30 degree angle of incidence. For this we will get the angle of emergence as 77 degree, and angle of deviation we will get as 47 degree. Now what you can observe from this values for our reference I have shown here. Let me draw the graph for the variation of the deviation with the angle of incidence. Let me draw here variation of the angle of deviation with the angle of incidence. Angle of incidence. This is what angle of incidence. And what is this delta? Angle of deviation. Angle of deviation. Delta is angle of deviation. Now, what you can observe here, if the angle of deviation, angle of incidence increases, angle of incidence increases, what happens to this deviation? First, corresponding to 30, what you have? It is deviation is 47 degree. Let us take 47 degree. Let me take here 47 degree corresponding 30. Now for 48 degree, what is the angle of emergence? 48, deviation is how much? For 36 degree. Let me show here for 48 degree. 48 degree. What is this? The deviation is 36 degree. 36 degree. Again for 70 degree, this is what 70 degree. What is the angle of deviation? 43. 43 means which is less than this. Let me take here 43. 40. Now, if you draw the graph, how do we get? So these are the points which are traced by taking these values on this graph. If you draw this one, you join. You can clearly observe from this graph that the deviation is minimum at particular angle of incidence. Is it? Where is it minimum? See that? What is that minimum value? 36 degree. Now, this deviation we call as a angle of minimum deviation. For this prism, what we have taken? We have taken here triangular, equilateral triangular section of a prism. For this prism, 36 degrees is the angle of minimum deviation. Once you can observe clearly that for this minimum deviation, observe at minimum deviation, what are angle of incidence and the angle of emergence? Absolutely equal, is it? Absolutely equal. 48 degree, here also what? 48 degree. That means at minimum deviation position of the prism, at minimum deviation, just you take the light ray incident, slightly you rotate this one, angle of incidence increase and again increase. So that deviation will be first decreases and again increases. Meanwhile, it becomes minimum. That means we need to know clearly that only at minimum deviation position of the prism, minimum deviation position of prism, what happens, sir? Delta is equal to dm. Delta m is equal to dm. Deviation is equal to minimum deviation. Whereas you can understand that at this one, angle of incidence and angle of emergence are equal. That means I1 is equal to I2. Not only I1 is equal to I2, even R1, R2 values are also equal. R1 is equal to R2. Let me take it as R and let me take it as I. Please keep in mind that only at minimum deviation position only angle of incidence and angle of emergence are equal. And these R1 and R2 also are equal. From these values you can understand clearly. Now by considering these values, let me take equation 3. What we have, A is equal to R1 plus R2. That means from equation 3 you can write A is equal to R plus R, which is equal to 2R. Therefore A is equal to R is equal to A by 2. R is equal to A by 2. Similarly, from the equation 4 represents delta is nothing but dm. Dm is represented as minimum deviation, angle of minimum deviation, that is equal to I1 plus I2. Means I1 and I2 are equal, so that I can write here I plus I minus A. That represents here dm is equal to 2I minus A. From this we can write I is equal to A plus dm by 2. Only for minimum deviation, position of minimum deviation of a prism. Now, earlier we have discussed at the starting, what do you mean by the laws of refraction? When you apply the laws of refraction at any phase, at that phase we need to see the angle of incidence and angle of refraction, and these refractive distance of these prism and surrounding medium refractive index n1. Let me apply the Snell's law of refraction into first phase of the prism, or even you can apply to the second phase of the prism. Applying the Snell's law at first phase of the prism, AC, what you can write here, n1 sin I1 is equal to, here what is the refractive index of this medium, n2. What is this angle of refraction here, r1. So what you can write here, n2 sin r. n2 sin r1. Now let me take this n2 to this side and sin I1 to this side. N sin r1 to this side, n2 by n1 is equal to sin I1 by sin R. Now N2 by N1 is called relative refractive index, which is the ratio of the refractive index of the second medium to the refractive index of the first medium. This is also called as the relative refractive index, which is refractive index of second medium with respect to first medium. N21 is equal to sin I1. I1 or I2 both are same, and that I value what we know A plus Dm out. Let me substitute instead of I as A plus Dm by 2 sin A plus Dm by 2 by R1 is what A by 2 sin A by 2. This is called the Prism formula or Prism equation. Let us take this as a fifth equation, and this equation 5 is for Prism formula. This is what we call as a Prism formula. So very important. What is this? N21 is equal to sin A plus Dm by 2 by sin A by 2. A is what we know, angle of prism. Dm is the minimum deviation. N21 is the refractive index of the second medium with respect to the first medium. Refractive index of second medium with respect to first medium. Then this is the Prism formula for a minimum deviation portion. And here let us raise some questions regarding to this prism. When we have seen this diagram, I have drawn that the refracted ray is bending towards the base of the prism. Moreover, you can observe that this refracted ray is parallel to the base of the prism. And my question is that, is refracted ray always parallel to the face of the prism, base of the prism? Is refracted ray always parallel to the base of the prism? Is refracted ray always parallel to the base of the prism? Just to think what will be happen. Is it parallel always? If it is not, why is it not parallel? Or when is it parallel to the base of the prism? And moreover, when we have taken the triangular section of a prism, the light rays which are incident on these faces of the prism, now refracting faces are having certain angle. They are at certain angle, so that you can observe that incident ray and emergent ray are making some angle. And previous to this topic, we have seen that the refraction of the light through the glass slab. When you have taken refraction of the light through the glass slab, let me remember once. Let me draw here only the diagram. Let me draw here diagram. So if you have taken the glass slab, so light first incident on this first face of the prism here, glass slab, and again getting refracted inside, and again emerged. So incident ray extend. This is what emergent ray. You can observe that this direction of incident ray and the emergent ray, how are these two? What is the angle between these two? What is the angle between these two? 0 degree. That means what is the deviation? There is no deviation, but laterally they are shifted. So what we can observe there, lateral shift is there, for a light ray which is passing through this glass slab. Moreover, the direction of incident ray and emergent ray both are parallel to each other because these faces of the glass slab are parallel. Therefore, incident ray and emergent ray are also parallel. But for this prism, these faces of the prism are not parallel. They are making certain angle. So that what will happen? Incident ray is deviated. They are not a certain deviation we have. This is what we need to understand. The conceptual based questions relate to this one. I hope you understood for this from this topic that the deviation of the prism for a light is dm. At dm, angle of incidence and angle of emergence are equal. From this minimum deviation position, I have seen only the deviation is minimum at that position. So let me answer the question whatever I raised. Is refracted ray always parallel to the base? No. Always it is not required to be parallel. Then when is it parallel? Yes. Only at the deviation, minimum deviation position only. That means the angle of incidence and angle of emergence are equal. Only for that deviation is minimum. In that case only, this refracted ray is parallel to the base of the prism. Other than these angles, then this refracted ray is not exactly parallel to this, but it makes some angle. So I hope you understood this prism formula and concept behind of this prism. How is the light will be refracted? Let me discuss what would be the factors affecting on the deviation of the prism. Here we know the deviation of the prism already we studied, we discussed about the angle of deviation changes with the angle of incidence. How is it changes with the angle of incidence? As the angle of incidence increases, first deviation decreases and becomes minimum, and after this angle again it will be deviation will be increases. So how it will be the changes? How it will be changes with the angle of incidence? Angle of incidence. Let me see here angle of incidence, that is one factor. But let me first discuss about the for small angular prism what would be the deviation. For small angular prism, we know already for small angles sin theta is equal to theta and tan theta is equal to theta. That means sin 0 is equal to 0, tan 0 is equal to 0. That very small angles. For those you can take that sin theta is equal to theta. Let me write here sin a plus dm by 2 is equal to a plus dm by 2. Similarly, sin a by 2 is equal to a by 2. You substitute these values in this equation present formula, whatever we have. n21 is equal to a plus dm by 2 by a by 2. 2 cancel and bring this a to this side. n21 into a is equal to a plus d a plus d. Now we need dm, minimum deviation. Bring this theta to this side. Then dm is equal to what again? n21 minus 1 into a. This is the minimum deviation for a small angle prism. A small angle prism. For small angle prism. Then we go for the factors affecting the angle of deviation. Already we have seen the deviation changes with the angle of incidence, and how is it changes with the angle of incidence that we have seen. First one factor, angle of incidence as angle of incidence I increases, the angle of deviation first decreases, and becomes minimum. So that is what we have seen here already from the graph whatever we have drawn, becomes minimum, thereafter again increases. And how is it depends upon angle of prism. Then let me show angle of prism A. So factors which are affecting deviation. From this expression you can see that the dm is the minimum deviation, that is equal to n21 minus 1 into A. So n21 is nothing but the refractive index of the prism which is remains constant. Therefore the deviation is directly proportional to the angle of prism. Then the minimum deviation is directly proportional to the angle of prism. As the angle of incidence, angle of prism is more, angle of deviation is more. Angle of prism is less, angle of deviation is less. And let me show how this depends upon refractive index. Refractive index. Refractive index. We know already refractive index of the prism. From this expression, the deviation is directly proportional to the refractive index. The more is the refractive index, more is the deviation. Less is the refractive index, so less is the deviation. For example, if you are taking, we have different types of the glass prisms. We have this one ordinary glass prism, and even we have crown glass, flint glasses, and ruby glasses, and even these diamond, different glass prisms we have, but different glasses will have different refractive index, different mediums are having different refractive index, so that I can write here for example, if you have taken for crown glass, refractive index is equal to 1.53. And for flint glass, refractive index is equal to 1.65. 1.65. Now tell me, which is having more refractive index? Is flint or chrome? Flint glass is having more refractive. Then what about the ordinary glass refractive index? As we know that is 1.5. Refractive index has no unit. Here I didn't write any unit for the refractive index. Then we can write this refractive index, that means deviation of the flint glass is greater than deviation of chrome, because more is the refractive index, more is the deviation. Similarly, always it depends upon the wavelength or color. Wavelength or color of. We know already the absolute refractive index is the ratio of the speed of light in vacuum to the speed of light in a medium, and that is the refractive index is inversely proportional to the wavelength. Refractive index is inversely proportional to the wavelength because it is directly proportional to the refractive index. Therefore, the deviation is inversely proportional to wavelength. We know from violet to red is having wavelength increasing wavelength. So violet is having less wavelength, red is having more wavelength. Then which color is having more deviation? Violet. Why? Because the wavelength is less, so deviation is more. Therefore, deviation of the violet is greater than deviation of the red. These are the factors affecting the refractive index of the prism. Angle of incidence. First, how it depends, and angle of prism, it is directly proportional to the minimum deviation. More is the angle of prism, more is the angle of deviation. Less is the angle of prism, less is the deviation. Refractive index, more is the refractive index, more is the deviation. Less is the refractive index, less is the deviation. So that here we have discussed today about the refraction of the light through the glass prism, how it will be refracted through the glass prism, what will be happening. Then in next class we have to discuss about the whenever the light is incident on this prism, for what angle of incidence the light ray does not come outside. What would be the condition for the no emergence? Okay. And even how is the light ray? For example, if the light ray is incident grazing. Grazing means what? Incident perpendicular to the normal. So like this grazing along the surface. Along the surface. When it is incident, in that case, what would be the conditions? Then what would be the condition for no emergence? What would be the conditions for grazing emergence? And these things we discuss in the next class. And let us see some questions regarding to this deviation. A thin prism having of angle 5 degree, deviation is 3.2. For small angle prism, example, angle of prism A is equal to 5 degree and deviation is given 3.2 degree. Deviation is given 3.2 degree. Then what is the refractive index of that prism? Refractive index of the prism N is equal to what? Look at this one. What is the angle of incidence? What is the angle of prism? 5 degree. That is what? Less than 10 degree. If the angle of prism is less than 10 degree, it is what type of prism? Small angle. For small angle prism, what is the deviation? N21 minus 1 into. That means deviation is equal to N minus 1 into 8. That is what we substitute. D is equal to 3.2 degree. N is equal N minus 1 into A is 5 degree. Then N minus 1 is equal to 3.2 by 5. Then N minus 1 is equal to 0.64. Therefore, refractive index of that prism minus 1, if it comes to this side plus, then 1.64 is the refractive index of that prism. So, we have seen in a detail about the refraction of the light through the prism and what will be the factors affecting the prism, what will be the deviation for small angle prism. We have discussed today, and in next topic we will go for the conditions for the emergence of the light and conditions for no emergence of the light, and thereafter dispersion and formation of the rainbows. And before that, you be prepared well of whatever we discussed today's topic, and you raise the doubts regarding to this topic through the our channel or through college mobile numbers. Thank you for watching and be prepared well. All the best.